All right, class. This is Sergio Silva Jr. I am recording a video here for our week 3 discussion board, and I am choosing option 1. Um, my two references that I'm going to be using is actually the YouTube channel and the video from our optional resources folder, and that's Memorable Psychiatry and Neurology, the name of the channel, and the sub-channel being Memorable Psychopharmacology. And our textbook, of course, Sinicola et al. From 2020. So we will be talking about neurotransmitters, the chemicals that are essentially responsible for all neuronal conversation, from sending messages from one neuron to the next. Embedded in this, the information is embedded in these neurotransmitters. So we're going to talk a little bit about a few different processes, starting with downregulation. Downregulation is essentially cells um, the cells push for homeostasis in a fluctuating environment. For instance, you take drug X and your system gets completely overloaded with, say, dopamine. In a way for that cell to maintain homeostasis, it reduces the sensitivity of the incoming cell, of the postsynaptic neuron rather. And so it removes a lot of the receptor sites. So the neurotransmitter in question, the dopamine, for instance, doesn't bind to every single receptor site there is, overwhelming the system in general. So again, to try to find homeostasis, it removes some of these receptor sites, and so not as much of that flood of neurotransmitter goes into the system, and those messages don't get passed on as much until the point of signal termination, if that happens. And that's called downregulation. You see the exact opposite as well. You see upregulation happening, where if there just isn't enough of something happening, enough of a particular neurotransmitter being sent, or if there's only a couple of dopamine molecules hanging out in the synaptic cleft, which we will describe in just a second, the incoming cell might increase the postsynaptic neuron might increase the amount of receptors to make absolute certain, or at least higher the chances that that postsynaptic neuron will that these neurotransmitters will bind to the receptors on the postsynaptic neurons. So that idea and that process is particularly relevant with reuptake. And this brings in the kind of the main part of this conversation, talking about selective serotonin reuptake inhibitors and serotonin norepinephrine reuptake inhibitors, and particularly how those are meant to mitigate the symptoms of unipolar depression, essentially a major depressive episode. So there's these transporter proteins that get made in the cell body in the soma, and so kind of backtracking a little bit here, we have we have these vesicles that get filled with neurotransmitters, right? That the cell body has all the DNA for. They have all the information to produce all this stuff, and they send it all the way down to the bottom of the presynaptic neuron. And these vesicles let out these neurotransmitters. They go and hang out in the synaptic cleft, which is this tiny itty bitty little space where the neurons meet, the presynaptic and the postsynaptic. It's about 40 nanometers thick. For some context, human hair is about 70,000 to 100,000. Right? So these vesicles get opened up, and these neurotransmitters get spit out into the synaptic cleft, which ends up kind of allowing the postsynaptic neuron to grab onto these through their receptor sites. And depending on how many or how little they grab, they set off an action potential to continue the message forward onto the next neuron, or they terminate the signal if it doesn't have enough of a buildup to activate the action potential. And so, at least according to the serotonin hypothesis of depression, which is kind of brewing up in the 60s and really exploded in the 70s, where the first or the first SSRI was made and put on the market, they really put a lot of weight on serotonin, and they basically deemed depression as a lack of serotonin in the system. And digging a little bit into this, they furthered their explanation. They thickened their explanation by saying that it was potentially the body is potentially producing enough serotonin, but what's happening is the presynaptic the presynaptic neuron is sucking all of those back in with the transporter protein. So transporter protein goes and binds there at the end of the presynaptic neuron, and it sucks all these neurotransmitters that aren't being used out of efficiency's sake. The rest kind of go through diffusion and get diffused within the system. So an SSRI goes down there and they block off these transporter proteins, allowing an accumulation of, in this instance, serotonin or norepinephrine. The two work very, very similarly, and it accumulates. In addition to accumulating, it also allows it to hang out in the synaptic cleft a little bit longer, increasing the chances for them to bind on the receptor sites of the incoming of the postsynaptic neuron. And so it gets a little bit tricky because this process will show a rise of serotonin within hours. Um, However, symptoms don't appear really to get that much better until a few weeks or a month or so, sometimes even longer. And so a lot of professionals really kind of say that placebo is occurring here, and it really shows how infinitely more complex depression is than just allowing more serotonin to go from one neuron to the next. All right, so yeah, lots of work to be done here in this field. SNRIs are a little bit newer. They came onto the market in 1993, but it's essentially a very, very similar process. All right, thanks for watching.